Imagine the ground beneath your feet, solid, dependable, the foundation of your entire world. We take its stability for granted every single day. Now, imagine that foundation turning to liquid. Not for a few seconds of rattling, but for minutes on end. A level of movement so powerful it can physically shift continents. We hear about earthquakes all the time, a 6.0, maybe a 7.5. But those numbers hide a terrifying reality. The difference between a strong earthquake and a truly great one is almost incomprehensible. Today, we're not just looking at the numbers, we're looking at what a magnitude 9.0 earthquake really is, and what it looks like when our planet unleashes its ultimate power. To understand a 9.0, we first need a quick refresher on how earthquakes work. The Earth's surface, or crust, is not one solid piece. It's broken into massive sections called tectonic plates. These plates are in constant, slow-motion movement, grinding against, pulling away from, or sliding under each other. Most of the world's largest earthquakes happen at what are called subduction zones, where one plate forces its way underneath another. Sometimes the edges of these plates get stuck or locked together. For decades or even centuries, the pressure builds like a drawn bowstring. A magnitude 9.0 earthquake is what happens when that pressure is released all at once. This is known as a megathrust earthquake. It's easy to get lost in the numbers, but the magnitude scale is logarithmic. Each whole number increase represents about 32 times more energy released. So, a 7.0 releases 32 times more energy than a 6.0. An 8.0 releases over 1,000 times more energy than a 6.0. But a 9.0? A 9.0 earthquake releases over 32,000 times the energy of a 6.0. The sheer scale of energy is difficult to overstate. It's enough to slightly alter the tilt of the Earth's axis and shorten the length of a day. On March 11, 2011, at 2:46 p.m. local time, this theoretical power became a devastating reality off the northeastern coast of Japan. The Great East Japan Earthquake, also known as the Tohoku earthquake, was a textbook megathrust event. The Pacific Plate, which had been pushing under the Okhotsk Plate for centuries, suddenly slipped. The rupture zone was enormous, an area of the fault roughly 500 kilometers long and 200 kilometers wide slipped. In some places, the seafloor shot upwards by over 10 meters and lurched eastward by as much as 60 meters. This colossal movement of the Earth's crust generated the most powerful earthquake ever recorded in Japan's history, a magnitude 9.1. For the people on the ground, the shaking was terrifyingly long, lasting for an astounding 6 minutes. In a major earthquake, every second feels like an eternity. 6 minutes is an almost unimaginable duration of violent motion. Buildings in Tokyo, hundreds of kilometers away, swayed like trees in a storm. Closer to the epicenter, the ground itself failed. A process called soil liquefaction turned solid earth into a thick, unstable fluid, causing buildings to tilt and sink. But the shaking was only the first part of the disaster. When a section of the seafloor the size of West Virginia is thrust upwards by several meters, it displaces a colossal amount of water. This generated a massive tsunami, a series of waves that began racing across the Pacific Ocean at the speed of a jetliner. Less than an hour after the earthquake began, that wave reached Japan. This was not a cresting wave you might see at the beach. It was a fast-rising wall of water, a surge of the entire ocean itself. In some areas, the waves reached heights of over 40 meters, or 130 feet, higher than a 10-story building. They traveled up to 10 kilometers inland, erasing entire towns from the map. The force was absolute, carrying away homes, cars, ships, and infrastructure, creating a terrifying, moving debris field. The consequences of this single geologic event were staggering. Nearly 20,000 people were lost. It caused an estimated $235 billion in economic damages, making it the costliest natural disaster in human history. And its impact went far beyond the coast of Japan. The most profound secondary effect was the meltdown at the Fukushima Daiichi nuclear power plant. The earthquake automatically shut down the active reactors, but the tsunami, which far exceeded the height of the plant's defensive seawall, flooded the facility. This knocked out the emergency generators needed to cool the reactors. The result was a series of meltdowns and hydrogen explosions, releasing significant amounts of radioactive material. It became the worst nuclear disaster since Chernobyl. The Tohoku earthquake was a brutal lesson for the entire world. Japan was arguably the most earthquake-prepared country on Earth, with advanced building codes and a sophisticated tsunami warning system from the Japan Meteorological Agency. But the 9.0 event surpassed the worst-case scenarios that much of the infrastructure was built to withstand. It forced scientists and engineers globally to reevaluate the maximum possible magnitude for earthquakes in subduction zones. It led to the construction of larger seawalls, improved evacuation plans, and a complete rethinking of nuclear plant safety. It reminded us that nature can and will exceed our historical records and our scientific assumptions. A 9.0 earthquake is not just a more violent tremor. It is a fundamental reordering of the landscape. It is ground that shakes for minutes, not seconds. It is a force that moves coastlines, creates land from sea and sea from land. And almost always, it is followed by the immense destructive power of a tsunami. Events like the one in 2011 are humbling. They demonstrate the limits of our engineering and the scale of the planetary forces that operate constantly beneath our feet. While we cannot stop the next megathrust earthquake, understanding what one truly looks like, the prolonged shaking, the ground failure, and the inevitable wave is the first and most critical step in preparing for it. By studying these immense events, we learn to build better, plan smarter, and ultimately coexist with the powerful and dynamic planet we call home. Thank you for watching.
This video has been prepared after a lot of effort and struggle. We want you to comment on it, share it with your friends, like it, and always be happy. And one last thing, if you enjoyed our meeting, subscribe to the channel, and we will see you there.